whatsoever that he should be feeling embarrassed about it.
Yeah.
Yeah, no, that was you handled him well. I think we would all agree with that. Oh, it looks like we got is it Alien. Am I saying that correctly?
Yep, that's right. What's up?
How you doing, Alien? Thanks for joining us.
I'm doing well. Yeah. So I'm just curious. According to the premise that you guys have at the bottom of your chat, it says that God created only two human beings as beings at creation. Yesterday, you were saying something along the lines of evolution is possible, but it can only be de-evolution, that things can get less complicated than they started out. Is that right?
Well, genetics goes downhill over time. That's the point.
Okay, so the first two humans, like, I guess, sort of what are their characteristics? Were they black? Were they white? Were they red?
Brown.
Haired? Were they blonde haired? What exactly was
actually that's
the history?
That's a really good. Actually, that's a really good question. Matt did a really good video, and I can answer this too based on our model of pre-existing genetic diversity, but I think it's appropriate to let Matt there explain it, because he did a video solely on that. You know, what color was Adam and Eve? What were some of their traits, for example? Pretty well answering your exact question. Matt, what do you think, brother?
Yeah, I usually explain it in terms of genetics, but the best way of doing it will be just looking at a positive and our dominant and recessive. So inside of white people, we carry the recessive, so all lowercase letters. What that means is that when a white person has another child, they can only produce another white child because of that. Now, if they carry some dominant genes, like black people, they carry only the dominant genes. So when they produce, they can only code for more black-skinned people. However, the only skin color on Earth that can actually code for every variety of skin color is brown. So therefore, they would have had to be brown eyes, brown hair, and brown skin, because it's the only variety that contains all the genetic diversity to code for everything. See, in out of Africa theory, that would have made man split from a chimpanzee with black skin. But our model says that man was created in the Fertile Crescent, which is the Middle East, and the people in the Middle East have brown skin. So it actually not only validates the creation model, but it disproves the out of Africa theory at the same time.
So if we're saying that it's a de-evolution from black people to white people, are you a black supremacist?
No, that's not what he's saying. He's saying
the reason I'm asking that, to clarify, is we're saying that that creationism is that it can only de-evolve, it can only become less complicated, less sort of supreme than it started out, right? So if we started out exclusively as black, are white people somehow genetically less?
Well, no, I'll jump in real quick, Neff, and then let you take over. Pretty well what Matt is saying is if Adam and Eve are a mix of capital and lowercase letters, capital A, lowercase a, capital B, lowercase b, for example, and we're a middle brown skin tone, this has nothing to do with racism, well, then they therefore have the potential to produce every shade of skin that exists on the planet. This is basic Mendelian.
Right. No, I understand that. I understand that component. My question, though, is yesterday you were saying, I'm not sure if it was you, I think it was actually Logical Plausible who was saying it, but one of you was saying that we can only go downhill. We can only go to something that is less complicated, less sort of evolved, to something that is sort of simpler. So the example was we can go from a wolf to a chihuahua, but we couldn't go from a chihuahua to a wolf, right? So are we saying that
the reason being is
genetically superior?
Did you want to take that, Neff, or?
Well, it's like this. Genes get turned off, and they become recessive, and they eventually just don't get turned on anymore. And that's how you get a Chihuahua. By continuously breeding, you're turning off genes that make the animal big. You're turning off the genes that make it hairier. You're turning off the genes that give it a longer muzzle. You're turning off information. And so what happens is genes become recessive. They're no longer expressed in that gene pool, in that population anymore, if you have a population of that creature. But what's causing creatures to go downhill, that's a potential problem for evolution too. But what's causing organisms to go downhill since the creation is the fall is the accumulation of random genetic mutation, the negative effect of that building up in the genome of every species. That's what's causing mankind to go downhill.
And then let me just, I'm just going to add a point there, and then you can talk, Alien. We want to give you plenty of time to talk. But since you brought up, right, the first two people, so we would say Adam and Eve, for example, would have had these DNA differences within themselves. And then, of course, if we were to talk about the biblical kinds, well, that idea would apply universally among species. So, for example, each created kind, as well as Adam and Eve, they would have been front-loaded with these functional DNA differences that through a variety of genetic processes and mechanisms such as recombination, gene conversion, that could actually lead to the origin of species, and in regards to Adam and Eve, the origin of people groups. And then obviously we need to consider genetic drift, isolation, inbreeding, migration. Sure. But the thing is, a lot of these events, especially in animals, they are due to shifts from heterozygosity, so that's more allelic potential, allelic diversity, to homozygosity, so that's less allelic potential, so that's less information available for change, for adaptation. So it's a downhill process. When we look back to the creation event, we're looking back to the expansion of genetic information. Evolutionists, they look back to that single-celled ancestor billions of years ago. They're looking back to the contraction of genetic information, because you'd have to add a lot of genetic information to take your single-celled bacteria-like organism into a whale over time. So that's kind of our point there.
Did Adam and Eve have genetic diseases?
Not at creation, no.
Not at creation.
No.
So how do we get genetic diseases?
By genetic mutations. Mutations damage genetic information. Well, of course. Virtually all human diseases are caused by mutations.
Sure.
And the largest percentage of them are caused by the ones that cause deformity.
Is it Neff or is it Frey?
It's Neff.
The
ones that cause deformity can happen a couple of ways. They can happen to non-coding DNA. They can happen to homeobox genes, and they can happen to proteins that are critical in cell specialization and organization during development.
So for certain ones, so like sickle cell, and for example, having one code of sickle cell, right? Having one of your two being the sickle cell is actually beneficial, but having two is a negative trait, right? So I guess my question is did Adam and Eve, did they both have one sickle cell, or did they just not have it at all?
There's no reason to believe that they would have had any. There was no mutation taking place. Theologically, there was no mutation that occurred to man's genome or any species until after the fall. Okay, so God made them good, and they had no flaws in their DNA. Okay, so all diseases
was also throwing stuff away.
Yeah, so they wouldn't have had one. They wouldn't have had one mutation for sickle cell and then had to get another one to match so that the disease would make itself apparent.
Sickle cell is throwing something away. The sickle cell mutation, it's not beneficial in the sense that it's throwing a part of the protein away or whatever, you know what I mean? It's not new, it's not gaining, it's not becoming larger and more complex. It's just throwing away parts of the genome so it can avoid something like, sort of like Batman and Robin. Like Batman and Robin are chasing the Joker, and he blows up a bridge to stop Batman and Robin from getting to him. You know what I mean? It works for a while.
Yeah, I guess my struggle. The reason I bring up sickle cell is my struggle is that, like, if we're saying that it can only de-evolve, there are a lot of things that are evolving neither in a positive manner or in a negative manner, right? So I'm struggling with this idea of we started out perfect and it's only going down, because quite clearly having one sickle cell is beneficial, and having two is of course a bad thing, but having one is a genetic benefit, right?
Does someone want to explain to him 100 mutations? Because every generation born, we're having 100 mutations. Every single generation, near neutral ones that natural selection cannot see, and it's unselectable. So they're building up and building up and building up, and there's no way that they can get rid of them. So if you're getting 100 mutations, near neutral mutations building up every single generation, then how have we been going on for hundreds of thousands of years?
This idea that evolutionists have that mutation is the designer of fantastical things in the body plans of organized organisms, that it is the designer, that it is the builder of structural design, biological structural designs, is a myth. This is what evolutionists. Charles Darwin didn't know about DNA. Nobody knew what DNA really was until the early 20th century. They really began to fully understand what the DNA is. A package of information that defines an organism. It prescribes the organization of cells to make an organism. They began to understand that around the turn of the 20th century. And so they began studying organisms by mutating them. They would irradiate them. And see the effects of them, but because we have discovered that DNA is this package of information that prescribes the features and functions of an organism, not all of them, but certainly how an organism's cells are organized for the most part to make the animal. Because we know that today, evolutionists are stuck with they don't have a choice. They're stuck with having to believe that changes to that package of information is why the organisms morph over time to become fundamentally different types of organisms. Because if that process occurs, you have to have.
I'm just a little bit.
You have to have changes to the information.
Could you just clarify
to make that happen?
Neff, I'm a little lost. So I'm just trying to understand still. When we're talking about things that are both positive and also negative, so sickle cell is an example, but there's other examples might be certain neurological issues, right? So like you think about
example of evolution.
Yeah, so let's talk about so like dyslexia, for example, or a lot of people who are super smart from a scientific perspective are really struggle for biological reasons that are related to that in terms of their sort of social ability to interact with people, right? These are things that are both positive and negative from a perspective of sort of evolutionary benefit, if you will. So did Adam and Eve have dyslexia? Did Adam and Eve have right? If we go down all of these things, they're both good and bad is my issue.
Yeah, as I've explained, the theological position of the Christian is that there was no flaw in the DNA. They had no deformities, no genetic flaws, no biological flaws whatsoever in the beginning, and the evidence from genetics is that it's mutation changes to the original changes to the original package of information that God designed that is causing all the problems.
I just want to clarify.
Okay, so, well, just let me finish a sentence.
Well, I'm still kind of lost here, so I'm just trying to clarify. So you're suggesting that they're simultaneously they have the benefits of having dyslexia and don't have the costs of having dyslexia. They have the benefits of having one sickle cell, but they don't have the costs of having one.
Let me respond to this one real quick, Neff. Okay, so we are rapidly discovering that the vast majority of diseases we are beginning to discover are caused by a misbalance of certain aspects of gene regulatory networks, non-coding regions of the DNA, and a variety of other slight modifications, as Neff was referring to in terms of mutations. So just because and very often you're using very high IQ individuals as an example of having social issues. Well,
exactly.
A portion of that stems from very often there's a misbalance in some other portion of their overall operating system, if you will. There's an overexpression of different variables. So if you no longer have the balance, and therefore you're going to have a misbalance in your overall functionality. So it's not saying that Adam and Eve had to be dyslexic and not dyslexic, or have the benefits and none of the negatives, all that kind of stuff. That didn't even exist because everything was perfectly balanced.
So there
was no error, if you will, in the of the code.
To push on that a little bit, were they as smart as someone like Albert Einstein, for example, who had dyslexia, but simultaneously as capable socially as someone like?
Let's do a direct question. If there is, I don't know if you're listening to the response here. If they had the perfect execution of what was possible,
They would be both.
And no, they wouldn't have to be. Dyslexia wouldn't even be a variable, because dyslexia is only caused by a error in the source code. So if the error doesn't exist, then they can have both the genius and not have the negative ramifications that are often expressed in people that do have high intelligence. That's the entire point of.
But the point is,
hang on.
Those are simultaneous issues, right? Like the fact that Einstein was so capable intellectually is the reason that he was so struggled so much in terms of listening to authority, for example, or much in school, right?
Well, a large portion of that came from, and this is a very standard issue with high IQ individuals, is the reason they have a hard time in school very often isn't necessarily dyslexia. It's that they're so smart, they get extraordinarily bored with what they're learning because they grasp it in a fraction of the time. Intelligent, you must be dyslexic.
No, I'm not. I'm saying dyslexia is a specific kind of intelligence. Dyslexia is that there's a flip of your the way that your brain works, and so you're using your creative side of your brain to do certain tasks that are generally used by your functional brain, and so you're actually better at certain things and you're worse at other things.
Here's a remarkable observation. You're talking about things like dyslexia as an argument for evolution.
I'm using it as I'm trying to understand the idea of the perfect human, because I've never seen a perfect human, right? So when I'm trying to understand what the perfect human is, and therefore that we've all been derived from the perfect human, I want to be able to understand what that first perfect human was, right?
Alien, if you have 100% access to your creative brain, the creative side of your brain, and 100% access to the logical, analytical side of your brain, you do not have to have dyslexia in order to have access to that capability, is the entire point. If you do not have the errors which are caused by genetic corruption, which is what causes the dyslexia in the first place, if that doesn't exist, then doesn't mean you can't have access to a creative portion of your brain that you might not otherwise have access to. The only reason you wouldn't have access in the first place is because of genetic degradation in relation to the overall intelligence capability that is possible to be expressed.
Okay, so I have a dog. He's a total mutt, but let's pretend that he's a poodle for a second, because poodles are cuter. Okay. Is a poodle in every single way worse than a wolf?
Well, a poodle has its hair just keeps growing and growing. It's lost a part of its stop codon region that tells the hair to stop growing, so the hair just keeps growing and growing and growing. And if you don't cut a poodle's hair, then the hair will just keep growing until it dies. So there's nothing beneficial there. It's actually lost something. That's why it's a poodle, and that's why it has the hair that a poodle has.
My issue is that there's other ways in which I'd say that my puppy is better than a wolf. My puppy is certainly much nicer than wolves. I think that kindness is generally something that we'd consider to be positive, right? I'd say that my dog. Wait, Neff. I just want to. The reason I just want to like clarify what exactly I'm trying to frame.
My uncle owned a wolf. He owned a dingo, a huge dingo, a massive dingo, the size of the biggest German Shepherd you've ever seen. He was purebred too, and he was a pets as therapy dog. He used to go on, like my uncle used to take him, and retarded kids would pat him and stuff like that.
We're claiming that wolves are cuter and nicer than poodles.
I think the bottom line.
It depends on how a dog's raised, man. It doesn't matter what it is.
No, I don't think that's true. I think it's fair to say that a poodle.
Yes, it is.
Time out. We're going down a subjective thought.
Well, that's kind of the point, though, right? Like we're saying. Subjective. I agree, it is subjective, but the reason that I'm bringing it up, and I agree that it's definitely subjective, is when we're saying that this is that Adam and Eve were the perfect humans, and that everything derived from them is somehow sort of like a bastardization, a lesser version of those original two people. That seems to be something that's very subjective to me. In the same way that saying that a wolf is objectively better than a dog seems a little bit odd to me as well.
Well, you've got a bottleneck where superior people go into a severe bottleneck, which lowers the gene pool and messes with genetic diversity, and then modern man comes out at the end. Like supposedly, like we say superior genetically, but you say inferior genetically, and they go into this bottleneck, and then at the other end of the bottleneck, this modern man comes out from this You know what I mean? Like from these sort of not quite human, subhuman type creatures. It's
yeah. So the reason
that we're getting. And you always say we're getting faster, bigger, and stronger when the evidence is right there in front of your face.
I don't say that. I don't say that. I say that we're.
Well, evolutionists do. Evolutionists say that.
Yeah, to clarify, when I'm describing evolution, I'm not saying that it's getting better in a sort of a straight line. It's always better than the generation prior to it. Obviously, that's not the case. I think that most of evolution is simply different, right? But difference over periods of time. That difference, the ones that survive are the difference in a better way, and the ones that die off are the different in a less good way, right?
The problem for evolution is this: evolution allegedly explains the arrival of features, not the loss of them or the variety of them. There, how organisms' features can show variation doesn't provide support for the evolution theory.
Sure. So, Neff.
So let me give you an example.
Go for it.
Longer hair or shorter hair is still hair. Okay, losing hair, that's not going to help evolution. Evolution allegedly explains where hair came from.
Wait, so
getting
that's not true.
No,
but Neff,
getting smaller.
Can we focus on that one of the hair?
Getting this kind of the variations that we see, changes to the muscularity or the height, the weight, the girth of creatures, how long a tooth is or short a tooth is, will never bring a fundamentally different type of organism into existence. That's the problem. So all this jostling about variation.
Wait, no, I just want to focus on the hair.
I'm almost done.
Can we just move back to the hair?
All this jostling about variation won't provide evidence for evolution.
Can we move back to the hair?
The simple question for problem for evolution is, how do you get the wolf?
Sure.
That's
so can we move back to the hair?
Evolution.
Can we move back to the hair? Okay, so the hair, I think, is actually a really good example of something that is beneficial in certain circumstances and actually bad in other places. So this is sort of my problem with Adam and Eve, and the Adam and Eve are perfect idea, because if you're in Alaska, for example, being quote unquote perfect would mean that you're super, super hairy, because it means that you need to stay warm because it's freezing in Alaska. But if you're in Singapore or in Ecuador, now all of a sudden it's beneficial to be almost hairless, right? Or literally hairless. And so the benefit of hair isn't something that's sort of a universal, there's a good thing and there's a bad thing.
Yeah,
it's something that is sometimes good and sometimes bad, right?
No.
So did Adam and Eve start off hairless, or were they super hairy?
No, hair does provide a function other than keeping the body warm. It also alerts you if there's an
That's why I said nearly hairless, right? I'm saying hair like a heavy mane of hair.
It also alerts you if there's a small creature that could sting you or cause a poison cyst to develop in your skin, crawling on you.
Right, so Nev,
okay. So
my question isn't whether they had hair.
Let me finish the statement. So, longer hair or shorter hair doesn't support the evolution theory. The theory portends to explain the arrival of hair.
Right, but Nev, my question is
the problem is,
Nev,
you're never going to get a fundamentally different type of organism by varying the.
Simple.
Let me finish the statement, sir.
So what we'll do is we'll let Neff finish all his thoughts uninterrupted.
Yeah, that's fine. Yeah, we do that.
But I want to be fair. Then we'll hand it over to you, and then
I appreciate it. That's totally fine.
And then you give all your thoughts uninterrupted.
Yeah, no, I apologize. Yeah.
All right. Okay.
So, all right.
I think we both recovered from T-Jump. He interrupts a lot. So
you'll never get a fundamentally different type of organism by varying extant features. That's the thing. And we don't know of a mechanism where new features come into being. There's no evidence in genetics that genetics incrementally changes the body plan of living things to change anatomy. Just don't have any evidence for that. In 85 years of studying mutation, no journal has ever published, we observe mutations to be accruing and changing the anatomy of an organism, and incrementally something new is arising in the body plan that's passed on infinitely in animals, generation upon generation. We don't, nothing, absolutely zero, nothing. Okay, so changing how varying the feature of an organism doesn't give rise to new features, which is what evolution has to have. So talking about how beneficial or this longer hair or shorter hair might be, the creature still has hair, and if it could lose hair, that's fine. It can lose hair, no doubt it can lose hair, but you have to explain the arrival of hair. That's what evolution has to explain.
Okay, go ahead, Alien. Take as much time as you need.
Yeah, absolutely. So, okay, the reason that I'm concerned about this is because the first two, if we're claiming that Adam and Eve were the first two humans, these first two humans either were super hairy because they lived somewhere like Alaska and they needed to keep warm, or they were, as Neff says, I'm not saying that they were literally hairless, but that they had relatively little hair because they were in a warmer climate. The thing is that the needs for us to survive are different when we're in a hot climate than when we're in a cold climate. And so this is sort of the basis of evolution just in general. When we're talking about evolution, it's not about like better or worse just as a general term. It's better or worse for the specific scenario that you're in. So when I look at a dog or I look at a wolf, when I see the wolf, I'm saying, oh, this is a wolf and it's doing really well for the circumstance that it's in. It's really aggressive. It's going out there and it's killing stuff all the time. And that has to be what you do when you're in the wild. But now let's take that on the flip side. If you are in the circumstance of human populations, if you're a super aggressive dog, we're going to put you down, right? We don't want a wolf in our human society. To be a successful dog is different than to be a successful wolf. To be a successful dog, you have to be pretty polite. You have to be cute. You have to have floppy ears. You have to, pant all the time. You have to sort of bark in a cheerful manner. You don't want to start howling in the middle of the day, even though that's very much something that you should do as a wolf.
If I can jump in there real quick, just to even clarify Neff's point, and I appreciate that response there, Alan. I think what you're talking about is just basic changes in allele frequencies and populations over time or generations. But I think what Neff is saying is that type of, let's call it micro evolutionary variation. Okay, I'm sure we can all agree on that, where we're getting the changes in the frequency of say the expression of these different traits. Nobody here in this stream is disagreeing with that. But what Neff is saying is that type of micro evolutionary variation only explains the survival of the fittest, right? Who's reproducing more, but not the arrival of the fittest. So Neff's just asking, not for examples of small scale variation like short hair, long hair, but what he's looking for is the major innovations, major origin events,
Sure, absolutely. So to clarify, what you're saying there is that that it's not necessarily that that Adam and Eve were sort of the best humans, and that everything else is going to be a less good version of them, but simply that they're a different version of humans, that they're the original version of humans, and then from there we've all sort of shifted into different directions because of what advantages us and what advantages our children.
That wouldn't be supported by the genetic evidence. The genetic evidence implies that Adam and Eve would have been the best. They would have had the best genomes.
Okay, so but Neff, if we're going to say that they're the best, then you'd have to clarify: is the best long hair or is the best short hair?
The best is the least.
I just want a quick answer to this.
The best is the least changed by mutation.
That's not an answer. Is the best short hair or long hair?
Let me address this.
Wait, can I just quickly get an answer to this one?
I'm going to answer the hair question directly.
Okay, yeah, go for it.
Okay, so they neither have to be hairless nor hairy, because, and this is a well-documented fact. And are you familiar with the concept of methylation of genes and epigenetics?
I could use a refresher. Go for it.
Okay, short version, epigenetics is methylation. It's where a different gene basically can be turned on and turned off during the life cycle, and then some of these modifications can be passed on to the next generation, but they are gone within. It's not new data being expressed. It's things being enhanced or completely turned off or minimized. So to answer your question in regards to hair, and this is a well-documented, well-researched concept, the long hair, short hair is a direct epigenetic modification. So if you go live in the cold climate, you can have longer hair or more body hair. If you're living in a warm climate, then those genes get turned off. So the point is that in the context of Adam and Eve, if they have but this whole concept requires the data in the DNA to be available to allow for a maximization, minimization of the function. In this context, which is hair. So, in the context of Adam and Eve being the perfect version of the beginning, is they had the capacity to do all of these different variables.
Oh,
if they didn't, then and that's what we're talking about in the context, and not just in terms of epigenetics, but we're talking about this in the context of Adam and Eve and the original animals being, if they have all of the variations and the data that is required, it doesn't mean that all of it has to be expressed at any one time. It just means it has to be available to be expressed in the context of different variables, which is why I say all the time that God is the greatest programmer of all time, because he allowed for the if-thens variations that of what could possibly occur to be accounted for.
Okay, so we're saying
the general context.
So we're saying that they have the capacity to have both either long hair or short hair, but not that they have simultaneously long and short hair. Is that correct?
Correct.
Okay, so similarly, that would suggest that they would have the capacity to either have dyslexia or not have dyslexia, but they don't simultaneously have the benefits of dyslexia and the problems of dyslexia. Is that correct?
Plus, they've got the capacity, if their genome's corrupted when I say the right way, I don't mean anything good about it, but when their genome's corrupted in a certain way, then they're going to have dyslexia. When it's perfect and it's uncorrupted, then So basically, it's there. It's just waiting for the wrong mutation, the wrong corruption, the wrong deletion.
But the point is dyslexia
and then it arises.
Like the hair. The point is that dyslexia is like the hair.
No. The dyslexia is a deletion of data. It's caused by a deletion of data.
No, that's not accurate. That's not accurate. Well, that's just not what dyslexia is. Dyslexia is that there's a flipping of the brain.
The cause?
What is the cause? It's a different piece of your brain.
But what is the root cause? This has been researched quite a bit, and there's plenty of papers on this, that there's genetic factors and errors. They did twin studies on this, all sorts of stuff, that showing that when there's errors and mutations and lack of expression of certain types of genes, they don't know all the right ones, but
that's the problem, though. It's not an error. It's not something that's simply a deletion. It's an addition as well, because the difference is that it's a different part of your brain that is responsible for different for the same tasks.
The brain,
right?
What is responsible for the brain coming into existence?
I don't understand what that has to do with dyslexia.
Okay.
It's an addition. He said, "Is a copy."
What makes the cells? What makes the cells in the brain?
What makes the cells in the brain?
What is the source of the structure of the cells?
Yeah, it's made of atoms.
No,
it's chemical reactions between atoms.
Obviously, atoms as well, like molecules, but what is required for the different types of cells in the brain to be manufactured by the ribosomes and the proteins?
Chemical reactions? I don't know. What are you looking for?
We discussed this the other night. The genetic code and the information, the sequences which enable it to happen.
Oh, yeah, right? Sure.
Okay.
Sure. Yeah.
So
but that's the point. There's different
cells and the errors. The errors in the neurons and the errors in the variety of gateways and switches.
That's my point.
The point is that the outcomes.
It's not simply a deletion. There's an addition as well. When we're talking about the differences between a dyslexic brain and a non-dyslexic brain, there are both additions and subtractions to a dyslexic compared to a non-dyslexic brain, right?
Are you talking about function, or are you talking about
I'm talking about like
the
literal. If you looked at all of the full information being held in a dyslexic brain and compared it to the full information being held in a non-dyslexic brain, there's different information. It's not simply that there's less than one. It's that there's different information.
You're looking at capacity.
Dyslexia is
not what the cause of the differences is.
No. I'm just saying.
You're like.
But dyslexia is not a positive thing.
My point is not. My point is that it's not simply a deletion of things. It's also an addition of something else. Right?
But it's not a positive thing.
But it has an addition.
Wait, but Neff, that's simply untrue, right? Because when we're talking about dyslexia,
it doesn't support evolution because it doesn't change the structural.
Neff,
it doesn't change the structural design.
when we're talking about dyslexia, we're talking about Albert Einstein. It's quite clear when we're talking about dyslexia. It's quite clear that it has the effect, admittedly, of making it much more difficult to learn to read, but it also has the effect of substantially more creative ability.
Okay, so
this
the
is true
bottom
of
line
Albert
is
Einstein. This is true of Frank Lloyd Wright. This is true of a huge number of the creatives that we know had serious mental quote unquote disabilities.
If that being said, it doesn't matter. It doesn't support evolution because it doesn't change anything about the structural design.
My point is simply that it's both a positive and a negative. It's
are
not
you trying to say
that won't support evolution?
Are you trying to say that
about things that don't?
Are you saying that there's a trade-off a lot of the time?
Exactly. Yeah, that's exactly what I'm saying. There's a trade-off. Exactly right. So if there's a trade-off, then we can't say that there's this one thing of the non-dyslexic brain, and then something was deleted to get to the dyslexic brain. It was also something was also added to get to the dyslexic brain, right?
Okay.
The problem is
the question would be, and then and Neff, I'll let you elaborate on it. Is that trade-off actually sustainable? Because if the vast majority of mutations are deleterious, and we're accumulating 100 new mutations per person per generation, and now we know that our genetic code is vastly more functional than evolutionists previously thought, that means the degradation problem due to the mutations is a lot faster than was ever predicted. And most of these beneficial, sickle cell anemia, I mean, we can point to 100, they're mainly reductive, which means things are not being taken forward, they are degrading. So yeah, there might be a trade-off, a benefit here, a negative here.
Yeah, so can I respond to that?
Sure, go ahead.
Okay, yeah, absolutely. So you're totally right. You're absolutely 1000% correct that the majority of changes that happen to our DNA are negative. You're absolutely 1000% correct in that sense. The issue, though, is that when we're talking about both things that are happening positively and also things that are happening negatively, the positive traits are going to stick around for many generations because the people with the positive traits or the animals with the positive traits are going to be able to reproduce more efficiently than the ones with the negative traits, right? If you have negative traits, you're probably going to die in infancy. That's the case of many people and animals that are born with genetic defects. However, if you have 1 in every 1,000 of the children that are born with genetic quote unquote defects are actually benefited because of those quote unquote defects, then the people or animals that have those defects are soon, eventually, going to become the majority of that entire population, right?
Right, and I appreciate that response. See, here's the problem, though. Okay, so while the genome is degenerating in so many ways based on the accumulation of these nearly neutral mutations, because those are the ones, Alien, they build up in our genetics, but natural selection can't see them. They are essentially invisible to natural selection.
Yeah, I agree with that.
Even though, okay, good. I'm glad that we're on the same page.
So I agree.
I'm almost done.
Yeah, go for it. I'm sorry.
So even while there may be, a few adaptive gains that are observed, so many nucleotide sites are being degraded. So you're basically you're basically throwing out all of this information from lots of these nucleotide sites, and then you're trying to replace all that information for a few single desirable beneficial mutations. But the question is, can a few beneficial mutations actually counterbalance the damage?
Yeah. So I'm not sure how much of a coding background any of you have, but in coding, there's something that we do where you basically have, like, let's say we're playing like Flappy Bird, for example, just because I'm old and that's whatever. So Flappy Bird, the goal is to not hit the above or the below pipes, right? And so they'll just jump, and if you just start going randomly, right? The vast majority of the first jumps that you'll have will jump directly into a pipe because those are accidents. They're total just random chance encounters. And so that random chance is going to hit you into the pipe the majority of the time. However, the one that survives is the one that reproduces. And so what we do in coding is that we keep that one piece that is able to actually go through that first hoop. And then it gets to the second hoop. And then the one that gets to the second will go to the third. And so the point is that we're selecting the one that's able to jump through is the one that we're selecting for. And then over many generations of, basic mistakes, right, you actually end up being able to beat the game.
This is Tolstoy.
Well, remember,
you're pointing
it's
to-
evolutionary philosophy that's going to say that natural selection will be able to act upon enough, say, beneficial mutations to actually take that fish to fisherman, right? And according to evolutionary theory. But the question is, can natural selection actually eliminate the accumulation of these harmful mutations? You even admitted, Alien, that most of them are negative.
Of course,
they're building up over time.
So in the Flappy Birds example, that's the point. The vast majority of the first 1,000 times that you try to do this with a computer, it will make terrible mistakes, of course, right? But the point is that they're learning from those mistakes. Not I shouldn't say learning, because that suggests sort of an intelligent system. But the one that's able to reproduce, the one that's chosen, the strategy that's chosen, is the one that was able to succeed last time through.
The problem I'm hearing is this, that you're pointing to things that might have a benefit to make an organism more smarter in some way, or more capable mentally in some way. Okay, but that just doesn't support evolution. That's the problem. See,
well,
let me explain. So let me explain. If you had a countless number of mutations that modified the brain and made the organism somehow smarter, sharper, whatever, more witty, it doesn't matter how many of those you get. Unless you change the body plan, the anatomy of the animal, you're never going to get a fundamentally different type of organism. There'll be no evolution. Smarter, the ability to survive, all that's great, and it would be necessary if evolution is true. The organism has to be at least intelligent enough somehow to get by, and it needs to be able to survive. It's got to survive, or it won't be passing on anything. So that may be true, but nonetheless, none of that supports evolution, because it doesn't change anything about the structural design of the animal at all. And unless anatomy changes, there can be no evolution. So really all you're doing is dancing around the theory with little stuff that really doesn't support the theory at all. You need to be able to explain to us how fish evolve into amphibian tetrapods.
When you see the structural
That's
design
the kind
of
of thing that you need to do.
When you say the structural design of an animal, what exactly do you mean?
Well, the various anatomical features that it possesses and their location in the body plan.
Okay,
This is what evolution portends to explain the arrival of.
Working with that definition real quick. Wouldn't, like, for example, the length of hair be part of that definition, right?
No, the length of hair is not an explanation for the arrival of hair.
Would intelligence be?
No, because any number of changes to the.
I just want to go through a list.
I'm explaining why. No number of changes to intelligence will change anything about the body plan.
But so it's not about the body plan, because hair is part of the body, right?
That's what evolution pretends to explain.
If
you have a lizard, you have a specific lizard, and it's able to endlessly survive. So it's got the survival thing down, okay? And it gets smarter. Great, it's getting smarter as it goes, but it still stays has all exactly the same anatomical features in the same location of the body plan. If that never changes, let me finish. And that never changes, then the lizard never begats anything over time that's non-lizard, and that's what evolution allegedly explains. So none of the things that you're talking about can be used as an argument for evolution.
But the point is that it's not the same anatomically, because if we're talking about so when we're talking about, for example, give me a second for just.
So if it got an endlessly larger brain,
give me like 20 seconds. I apologize. I have to go downstairs.
Okay. So here's the problem he's got. If the brain keeps getting bigger, well, it's got a bigger brain. Does that mean it's ever going to evolve into a fish, become a land-dwelling amphibian? No, you have to change a lot of things. So you have to change bones, tendons. You have to change cartilage. You got to get new arteries and veins. You have to have new tendons and muscles. You've got to have things that don't exist in the fish to get the land-dwelling creature, right? So a bigger brain by itself does nothing to move the organism in that direction. You see, and bigger features. All the features of the organism get bigger It's still the same creature. It just might become deformed and unfit to survive if by a process like that. But if the feature is getting larger and smaller, that's morphology, not anatomy. Okay, anatomy has to change for evolution.
Big difference, morphology and anatomy.
Right, morphology alone is not going to cut it. You get a human being with more muscles in their buttocks or calves than another one. Great. Now, how much did it change to become non-human? Well, none. See, so you have to have anatomical change for evolution to be true, and without that, there can be no.
So I just want to clarify what you mean by anatomical change, right? So when we're talking about, for example, your ability to swim, that's something that seems like hair, seems like something that is sometimes beneficial, sometimes it's not beneficial. When you're talking about some things, the weight.
Explain the arrival of hair.
Hang on.
We can get that.
When I stepped away, Alien, were you talking about coding?
Hold up, Josh. I just want to clarify.
Were you talking about coding?
Okay, well, why don't we let Alien ask the question? So Neff asked, what is the origin of hair? Take your time.
Yeah. So okay. My struggle is when we're talking about hair as something that can either be beneficial to have long hair or it can be beneficial to have short hair. When we're talking about something like dyslexia, it can either be beneficial to have dyslexia or to not have dyslexia. When we're talking about all of these different things, whether or not you should be cute or whether or not you should be angry, if you're a wolf or if you're a chihuahua, right? All of these different things, it seems to benefit different animals dependent on their specific circumstance. And so when we're talking about the fish getting to the human, well, that seems like a lot of individual processes that are happening, right? You start off with the fish might be able to benefit somehow if it starts getting closer to the shore, because that means that fewer predators are able to get to them, for example. Then once they're closer to the shore, then it might be beneficial to be able to crawl onto land for a short period of time, such that they can manage to collect food before they can get back into the water, right? You imagine something that's like approximately a crab-ish. Then you get to a point where you're able to get onto the land for a longer period of time. Then from there, eventually you're on land sort of long term. All of these things are micro changes, and they're changes like the hair that we're describing, but over many, many generations, they affect huge change, right?
Right. So what's the evidence that kind of change has occurred?
Yeah.
Where's the genetic mechanism? Where's the evidence in genetics that mutation is capable of accomplishing this kind of change? Because this kind of change for the fish to become a land dwelling, its shoulder girdle has to become endochondral instead of dermal. I don't know if you know what that means, but instead of its
there's a bunch of huge changes. Absolutely,
it has to be structural design. You've got to have new tendons, new muscles, new bones, new all that sort of thing. New blood vessels, new nerves. What is the evidence in genetics that new things arise?
Yeah, so I'm not sure how familiar you are with Darwin himself. I'm not sure how familiar you are with Darwin, but Darwin was actually basically focused almost exclusively on birds. When he was at his home, he focused with pigeons, and he was able to change pigeons a lot within his own backyard, and be able to sort of shift what they looked like, shift the way that they acted, shift a lot of different things. And then when he went, and that's very, very similar to sort of dog evolution that we've been talking about prior. But then when he went to his first excursion, he was able to realize, oh wow, here in the Galapagos, these are a bunch of different birds that all appear to originally have started off in the same basic framework. But then as they've gone to all of these smaller islands, they've actually changed because they're trying to adapt to that specific scenario. So
they have bigger beaks or smaller ones.
Yeah, exactly right. Right.
But here's the problem, though.
But Neff, I just want to.
That doesn't explain the arrival of the beak.
Right. So you're correct. It doesn't show the arrival of the beak. But let's talk about dogs for a second. Dogs, we can show the arrival of the floppy ear, for example. Right. Wolves in the wild don't have floppy ears, but we're able to show the arrival of the floppy ear because it turns out that floppy ears are somehow related to a particular interaction that puppies have with respect to humans. Right.
So show us the arrival of the ear.
Actually, they found that the floppy ears are actually a result of a broken gene that does that.
So that's the point, right? So broken genes is a weird.
Alien, hang on. Earlier, when I stepped away, I think I heard you talking about coding, right?
Mm-hmm.
Are you a programmer? Or a dev?
I'm not super well versed, but I'm friends with a lot of them. Yeah. Why?
Okay, so do you in your knowledge, do you do HTML? Are you full stack, HTML, CSS, front end, back end? What is your knowledge base? Do you do Python, Django, any of that kind of stuff?
I guess what's the question, so I can.
Well, I mean, just ask you a question. What do you know? HTML, CSS?
Why? I'm not like well versed in any of them, but why?
Okay, but you know how they work and what you do with them.
Approximately,
okay.
Yeah.
All right. So, are you familiar with like MVC frameworks MVC and like Node.js, Angular, any of those kinds of?
I'm confused as to what the question is.
I just asked you a question. Are you familiar with them?
I could use a refresher. Go for it.
Okay. Do you know what JavaScript is?
Sure.
Okay. So if I'm creating a web app and I'm using the Node.js to avoid having to have a complete back-end structure, right?
Mm-hmm.
And I create all these different functions inside of it. And then I'm going to apply, when I do the front-end slicing of the design and implementation, I'm going to rewrite the HTML and the CSS, right? And I'm going to make it responsive, because in the modern era, if you don't have a responsive UI, then you're guaranteed to fail. But in the concept where I'm going with all this is in the context of things like beak size changes and things of that nature. We're talking about the CSS3 and HTML5 ability to create responsive websites based on display size. But however, that does not explain, number one, where the web app that you're using came from in the first place, and all the different functions. In this context, we're talking about.
Oh, that's a wonderful question. Oh, I love you. This is a great question.
The overall architecture and the different logic rules that were created in order for the functions inside this web app to exist. So ultimately, you haven't the genetic code is just like the source code for the initial framework. Now, it doesn't matter if you have I don't think there's a person on this planet who's a dev that would ever think that somehow magically your web app is going to connect to the
love your question.
The Google Maps API without a intelligent agent being required to do so. Now, in the context of genetic advancements that would be from the evolutionary model that would be required for a new body plan to come into existence, we are not talking about slight modifications to an existing web app. We're talking about an entirely new web app creating itself. Now, just because you used MVC framework and different things of that context to build the first one does not mean that you compared it to another web app that had used the same framework and the same source code programming language. Nobody would ever conclude that the other one wrote itself, nor would they ever conclude that the new one evolved from the first one that they came across. And that is what, when you really boil it down to what is being argued by evolutionary theory, is that somehow,
this is a fantastic question. Yeah,
through copying errors and replicate, you're running a batch script to back up the data. Well, in this kind, you have to have a database. You're using Node.js, but let's say you're backing up your database and your source code, and somehow through copying errors, it turned from app number 1 into app number 2 with zero direction and by pure.
This is a fantastic question. So I would argue that we're all in the same basic app. So I was very careful about the particular app that I used there. When I said Flappy Birds, the reason I was using it was that the only goal of Flappy Birds is to not die. Right? You're trying to get through each one of those things in order to stay alive for as long period of time as possible.
Flappy Birds going to turn into Angry Birds?
No, not at all. And you're totally right about that.
But that is what's being argued by evolution.
So no, you're completely right, and I want to sort of further extrapolate from that. The only goal of any animal and of any cell of any form of life at all is to, number one, stay alive, and number two, reproduce. Right. This is something that Richard Dawkins goes into a lot of detail on in his first book. I'm blanking on the name of it, but I discuss it in the God Thesis Part 2. Actually, I call it the basis of objective morality. Actually, but so this is a really interesting question. Is our goal fundamentally different than the goal of other animals? In my mind, the answer is no, absolutely not. Our fundamental goal from an evolutionary perspective is simply even now, the reproduction of our genes and the continued survival of our genes. That's it.
Okay, you're now talking from a philosophical perspective. You're
dancing. No, it's not philosophical.
You've dodged the entire point that I was making, which is, could a web app or a mobile app ever turn into another one without a intelligent agent causing that to occur? Okay,
the answer is absolutely not.
Okay, so when you are talking about an entirely new body plan, you are talking about the equivalent of millions of lines of code that are different between the two of them. Yes, it is.
So here's the way. Here's the way.
100% you are.
Absolutely
so
right.
What we're talking about is the only. So the game of Flappy Bird is to survive each one of those levels, right? It's a very simple game.
Flappy Bird.
We're not talking about the cause. No, we're talking about causality, not.
I just want to be able to. I just want to be able to answer this. It's going to take me like 15-20 seconds to answer this. The goal of Flappy Bird is simply to survive to the next level. The goal of evolution is simply to survive to the next level. Okay.
No.
And so, wait, Neff, no. I just want to be able to sort of go into it for a little bit. I appreciate it. So given the goal is simply reproduction, the way that you reproduce in a cold climate is that you manage to have longer hair. The way that you reproduce in a hot climate is that you have shorter hair. The way you reproduce if you're a wolf is that you're very aggressive. The way that you reproduce as a chihuahua is that you're very cute. These are different goal. The way that you manage, the goal is still the same, but the way that you manage to go about getting to that goal is different.
What's happening is you're dodging everything there is to explain about evolution with microevolutionary changes that have no bearing on whether or not something is able to evolve or not. You're only talking about survival. Survival by itself is not evolution. Okay.
Of course it is.
Natural selection by itself is not evolution. Evolution, I'll say it again, allegedly explains the arrival of features. Otherwise, there is no evolution. If you never get the fish to change in its structural design, you'll never get the land-dwelling amphibian tetrapod. So all you're doing is talking about how an organism can change so that it survives, even if an environment changes, like longer hair or shorter hair. All that's great. That's fine. That explains how the organism continues to exist. That doesn't explain how one type of organism begats over successive generations a fundamentally different type of organism. That's what evolution must explain. We don't know of a mechanism.
But that's my problem.
I don't understand. None of the things that you're describing promote the idea, support the idea of evolution. You're only talking about survival. That's not good enough.
What do you mean by an attribute? If not the hair, if not the floppy ears, if not
the arrival of the ear and the hair.
I thought I already did. The goal. Okay, so I'll try again.
You have to explain it from a biological look.
Yeah, absolutely.
You're talking about it from a philosophical way.
No, it's not philosophical.
Let me finish. We all know the story. We hear it all the time. You're giving us a storyboard.
No, I'm not.
You're giving us a storyboard. You're not giving us scientific biological evidence.
Yeah,
that's what you've got to have. You have to be able to explain the ear, the arrival of the ear, not how an ear that already exists can turn down like those of a collie, but where the ear come from, or how did it get hair?
Oh,
these are the things you have to explain. Modifying the various features of an organism so that they're longer, shorter, whiter, thinner, fatter, skinnier will never change the anatomy of an organism, and it will never support evolution.
So I just want to clarify at this point. We're saying that an animal can get to a point where it has longer hair. We can get to a point that it's shorter, that it's taller, that it's nicer, that it's meaner. We can get from a place at this point from the perspective from say an otter to something like a bear, right?
You can?
Yeah, under the premise that you've already accepted, the idea that it can get larger.
No, I never.
Wait.
Now, let me address this again from a coding.
Can I just explain why I think that we've already gotten to that point?
No.
Can I explain why I think it?
Alan, you clearly have not listened to a word.
I just want to be able to see.
What we'll do is we'll give the floor to Alien to explain, and try not to use storytelling or philosophy. Tell us scientifically how you can, well, I guess in your own words, get from an otter to a bear, and then we'll allow either John or Neff to respond. Go ahead.
Sure. So, okay, if you are an otter, you are in the water, all the time. Well, okay, go ahead, Alien. Take your time. I don't quite understand what the meaning of if it's a storyboard is. When we're trying to explain something, it's going to be in the form of an explanation, right?
But you're not doing it with biology. That's what you got to do.
Well, I mean, if you wanted to talk about biology, you'd have Steve McRae on, or you'd have like Jackson Reed on. But I'm not Jackson Reed. Right?
We don't need lessons in the theory. We understand it already. What we need is the evidence for the theory, the biological evidence. We're not.
Wait, I'm a little confused. What you're looking for? Are you looking for the biological explanation of like how
the arrival of features?
For example, if we took every single dog that exists on Earth today and threw them into Alaska, over time, based on just basic microevolutionary change and variation and adaptation, all the dogs with short hair will probably die off, and all
exactly right.
we'll be left with is the dog that is like a husky, right?
That's exactly right.
For example, but that we can talk about those types of adaptations, those types of changes all day long, but that's not going to explain how your single-celled ancestor billions of years ago evolved into that dog that already has embryonic potential to go from short hair to long hair. I mean, this is just basic Mendelian.
Yeah, absolutely. So the answer is
big B, little b. We understand that, but we want to know how you're going to get your single-celled ancestor into the dog.
Yeah, so the answer is that it's this. So when we're talking about microevolution happening many times is the basis of macroevolution. So we say, like, I think that Standing at Truth's example there was actually a really good one. We are all of a sudden to a point where all of a sudden, pretty much wolf-like dogs. We get a bunch of poodles, but some of the poodles have slightly longer hair, some of them have slightly shorter hair. We put them all in Alaska. Only the ones that have longer hair are going to survive. And then the ones that are going to survive from that point forward are going to be the ones who are more aggressive because they're going to kill each other. They're going to go out and hunt. They're going to do blah, 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 blah. Over a period of a bunch of years, they're going to become very wolf-like. Now, from there, you might imagine some reason that being big starts to be a problem. So, for example, if you get siphoned off, this is the Galapagos example that Darwin himself talks about. If you get a bunch of them that swim to an island, but then get stranded on the island. So like four or five of them get stuck on the island, and then they start to reproduce. Because the food supply on that island is pretty low, it's going to be the smaller ones that actually are able to survive on that island. And so now all of a sudden you have smaller animals, not just the sort of like wolf sort of hybrid thing that existed originally. Now you have these smaller wolves. And then let's imagine that the ones in the mainland for some reason die off. Now you have smaller ones, and these smaller ones are going to go back. Now all of a sudden there's other predators. So all of this is happening. All of these small changes are happening. But if you talk about this happening many times over, now after a series of generations, you have something that is very distinct from the original dog that you started off in Connecticut, right?
Okay, so number one, in the context of the birds, this has been well documented well after Darwin, that the things like the beak and the body size are based on epigenetic variables, and the same species, same version of the finch in question, will change when the food supply gets better, and they'll go back when the food supply gets worse. This is a well-documented fact, not by creationists, but by evolutionists that went to the islands and studied the birds to figure this out, and that's what they discovered. It's epigenetic factors. So those are not new types of animal coming into existence. They are slight modifications. So again, as I said earlier, in the context of coding, they have responsive code that it's just like if you were looking at the exact same website on a mobile phone, an iPad, or a desktop. The same source code has the ability to modify based on the variations of its observation, and scenario and setting. It's the exact same logic. Now you switch from the desktop to the mobile phone, it changes. It's the exact same thing. You have a shorter food supply than the ones with the smaller nuts. I think a lot of times the finches, it was like smaller nuts versus bigger nuts. Those epigenetic factors came into the parents. It was not new source data. It was modification to existing data. Then it was passed on to 2 or 3 generations of those finches, and then when it modified, it was turned off. I mean, this is well documented, but it required the original source code variables to be in existence for that to occur. And that's the entire point of what we're talking about. You're talking about these minor up and down modifications that already, the functional capacity for that to occur already exists. It's not being added, it already was there.
So okay, I'm going to try to do this in a mathematical sort of way. So what we're saying is the finch goes from island A to island B, right? And then once it's in island B, it changes it adapts to be productive on island B, right? And then it's true that if you take an island B bird that is very good and very adapted to island B, that it can adapt back to island A, just as the island A bird originally adapted to become the island B bird. But now let's imagine, rather than just going from A, right? Exactly right. Yes.
Let me ask you a question.
Wait, Neff. I just want to go a little further. Now let's imagine, rather than simply going from A to B, that instead it goes from A to B to C to D to E to F to G, and then back to A. Because the difference is that now all of a sudden it's gone through a series of changes, a bunch of immense changes. It's so the first one, let's say, it becomes beneficial to be black rather than a brown bird, and then the second one, it becomes beneficial to be a small bird rather than a big bird, and then the next one, it becomes beneficial to be a hummingbird sort of flapping rather than a sort of long, whatever it is. All of these things are individual changes that are happening. But if all of these changes happen because of a bunch of different of environmental reasons, then when you get back to the first one, all of a sudden, when you get back to the first one, Jason, I just want to be able to finish it, if you will.
Sorry.
When you get back to the first one, it's fine. Don't worry about it. When you get back to the first one, now it is sufficiently different that it no longer makes sense from its perspective, from its ability to survive, to try to go back to being an A bird. It's now a different kind of bird that is able to succeed in the A environment, but with a different format.
So let me ask you a question. Is evolution a scientific theory, or is it philosophy?
I don't understand what's the distinction in your mind?
Well, you don't know the distinction? Is evolution a scientific?
Well, I'm a philosopher, so I think everything's philosophy.
But is it a scientific?
Yeah, sure.
Is it science that allegedly explains how fish begat amphibian tetrapods
so the way
and dinosaurs became birds? And is that scientific?
The way I'd respond to that is that I think that math and science and STEM in general is downstream from philosophy. So yes, it's a science, but a science is a subset of philosophy.
Well, I understand there's philosophy to it. So then my question is,
science in general
if it's scientific, then why are you giving us philosophy and not providing scientific?
Well, because we're trying to talk about the philosophical, like, meta level.
The problem
we're not
with
talking.
Let me explain
if we
the
were
problem.
talking,
here's the problem with that. Here's the problem.
I just want to be able to.
We all understand the theory of evolution and the story behind it. We all understand the various stories of evolution, and that's all you're giving us is the stories. We understand the stories. You don't need to repeat them. We can get them on Smithsonian and National Geographic all day long, and we've all seen it. We understand the philosophy of the theory. We understand the ideas that this happened and then another thing happened, and we got all that. You don't need to endlessly repeat the theory.
So the reason I'm talking at a level of philosophy,
but the problem is, if you don't ever get to the science of it, you never explain it. We understand the philosophy of it.
This is a good question.
So what you need to do, though, is
let's let Neff finish, and then we'll give Alien equal time.
Yeah, I'm sorry.
We get passionate. It's totally understandable. Go ahead. Finish your thoughts. Take as much time as you need. Then we'll give Alien the same courtesy, uninterrupted thoughts.
Yeah, no, I apologize.
Go ahead. No, that's okay. That's okay. Go ahead, Neff.
Yeah, you need to be able to explain, for evolutionists to demonstrate that evolution is true and it's scientific, they have to be able to show that, firstly, there's a mechanism that causes incremental change to the structural design of the organism. The structural designs that is changed, caused by mutation and selection, predominantly, is preserved in the body plan of that animal and passed on. That means it gets to the gametes, it gets to the germline cells, and it's passed on. And then further subsequent mutation will change the information that's already caused that change to cause an additional incremental change to that thing and that feature. And then it turns up in the germline cells and is passed on. And then this repeats over and over and over, so that the stinger in the tail of a scorpion comes into being when there was not one. Okay, that's what evolution has to explain. Now, for that, you need, because we don't observe in any of the body plans of any living thing any partly developed features, and because we don't see this in the fossil record, I'm going to say we don't, and because we have no scientific evidence that mutations accrue to cause this kind of change, I'm going to just flat out say we have zero evidence to evolution. But what you've got to show is, it's not, I understand that it's not logical to believe that we can observe, test in the laboratory a species of lizard, let's say, and mutate it, and then mutate its offspring and mutate its offspring. And they've done that a bajillion times, especially with fruit flies, right? And they don't see any structural design change except deformities that make the organism unable to survive outside the environment of the lab. But so there's no evidence been provided by mutating creatures generation after generation to produce this kind of change. And I understand for most species we shouldn't expect to be able to observe that to any significant degree in the laboratory in a human lifetime, according to evolution theory, right? I understand that. But then you need to be able to show that there's a mechanism genetically for it. But then, since we can't observe most of that occur in a human lifetime, what you're going to have to do is be able to show in the body plans of living things and in those in the fossil record that mechanism exists, because we can see the structural design change from generation to generation in those creatures that once lived on the earth. Okay, that's what you're going to have to show. You're going to have to show that kind of evidence. You can't just endlessly say, well, look, the hair can get longer or shorter, or eye color can change. An organism can get taller or shorter. All that's great. Take a fish and add all the fins to its body plan you want. You're still stuck with a fish. We don't even have evidence that the new fins.
All right, can I go for it?
Right. So instead of giving us storyboard after storyboard about what the theory says, because we've all heard that a majillion times, let us hear the scientific evidence for evolution, because it sounds to me, not trying to be rude,
that's fine. That's fine.
Everybody's time.
So I'll respond.
Thanks, Neff. Okay. And they only take as much time as you need now, and then we'll allow Neff to counter that after. Go ahead, Alien.
Sure. Okay. When we're talking about philosophy in general, the goal of philosophy is to be as based in fact as possible. So what the purpose of mathematics is, what the purpose of science in general is, and specifically evolution, is to be able to figure out the minutia. From the minutia, the goal of philosophy is to use that minutia to extrapolate something larger. Right. So the goal of science very much is to show, and we have shown, and everyone in this room is agreeing that we've shown the microevolution, that we can show that the individual A to B bird is possible, the individual finch that moves from one island to another island. We can show that this individual wolf, or not the individual wolf, but rather the the genetic history of this individual line can go from a wolf to a dog. And a dog and a wolf are clearly distinct. Now, admittedly, they are relatively similar to each other when you compare them both to a fish. However, the point of philosophy, whether that's in the context of scientific philosophy or that's the context of philosophy just in general, is to look at that basic data of, okay, it's possible for it to be done at this level, and therefore extrapolating that it can be done at a larger level. That's how philosophy works in general. It's not something I'm doing. Neff, I tried hard not to interrupt you, and I did it admittedly a little bit, but I just want to be able to finish. And so it's really important that we're approaching this from a sort of fair perspective. That when we're saying something is done at a macro level, we're not looking for every single point that entire history. What we're doing is we're connecting dots, and those dots do exist. We can see not just the individual ape, but we can also see a bunch of different animals that were somewhere in between an ape and a human. We can't just see the individual fish and then also the animal. We can also, or the mammal rather, but we can also see a bunch of amphibians and sort of things that were approaching, becoming closer to an amphibian from the fish side, and then from the amphibian side towards the mammal side. And so these things, these individual points on this overarching thing, is the reason that we're able to say it. But it's not as though, in order to prove, quote unquote, the theory of evolution, you'd be required to have every single point on the graph. It's just a matter of trying to connect those dots.
Okay, so my point is this: I say you took a leap when you said extrapolate. You say from microevolution we can extrapolate the macroevolution, and then you acknowledged, which I was surprised to hear you say, that we can show that these kinds of changes occur. That we have the physical evidence that one begat the other type, the other fundamentally different type of organism over time. And that's now we're beginning to get somewhere. Finally, after an hour of storyboarding, we're finally starting to get somewhere. So where are these forms, and can you explain how they show that, say, the fish became the land-dwelling creature or some other such transition? Where's that evidence? Because without that, everything you've given us is just what's in your mind. So the answer is something that can be substantiated, right?
So the answer is that we're not going to be able to show sort of this direct stream that you're proposing. We're going to be able to show individual points on that overall line, right? We're not going to get it like a father and their son and their son's son and their daughters, etc., all the way down the entire lineage.
Of course not. So where are the forms that demonstrate?
Yeah, absolutely. So if that's the question, I would encourage you to have Jackson Weed on, or I'd encourage you to have Steve McRae on, because they're the ones that are.
Do you believe they exist, or do you know of them?
I have watched their videos. I'm not an expert on that component. I'm a philosopher, right? So my goal is to explain this level of connecting the dots, right? Their goal, because they're scientists, is to focus on the individual piece by piece, finding those dots, right?
Well, you can philosophize and connect all kinds of dots in your mind all you want to, but that doesn't provide the evidence. The thing is, you need to be able to show with the physical evidence. And I'm going to say,
we've also debated them many times, so we're going to know what forms, what fossils they're going to bring up. For example,
but the struggle is
Matt has already addressed many times. So if you want, we can.
The reason I'm frustrated.
Let me share this one thing with you. Roger Lewin, who is a famous, used to be a biologist and a science writer. He's retired some years ago. He was probably the most famous science writer in the world for about 25 or 30 years. He was very prominent, wrote for Nature, wrote all kinds of articles, very prominent because he was a high-level biologist before he became a science writer. And he said this: in 1980, the biggest eggheads in the evolutionary theory field came together for a conference in Chicago. And the title of the Chicago was Macroevolution. And the question posed by these eggheads was, can we show that microevolution can be extrapolated as evidence for macroevolution? And Roger Lewin, who was present at that conference, said this. He said, The central question of the Chicago Conference was whether the mechanism underlying microevolution can be extrapolated to explain the phenomenon of macroevolution. At the risk of doing violence to the positions of some of the people at the meeting, the answer can be given as a clear no. In other words, the most prominent evolutionist biologists in the world came together for this conference, and Roger Lewin commented extensively on what they argued about and talked about, and he stated it was the consensus opinion of the men in that room that they could not show that macroevolutionary change supports the idea of macroevolution. So this has already been covered. Evolutionists have already acknowledged we can't show that microevolution can be extrapolated to show microevolutionary change can show macroevolution. So the point I'm making is this. All the philosophy and the connecting of the dots that you speak of in your mind don't support evolution. Okay, so I guess you have to move from there to the scientific, the physical evidence in order to do it. Because at this conference, even these prominent evolutionist biologists acknowledged that the kinds of changes you're talking about cannot be used to show macroevolution is a true process. Okay, you have to move from philosophy and connecting dots to physical evidence, be able to show macroevolution is true. Microevolution will not do it.
So I guess my confusion is this. The physical evidence that's going to exist is going to be points on the graph. It's not going to be the entire graph. It's going to be points on the graph. We're going to find fossils from individual points in the overarching history, right? And so, Neff, I just want to be able to finish. And so, when we're talking about that, like, that's actually it's very much something that people like Jackson Wheat will spend their whole lives on, and get really, really, really good at answering. Where are these dots? And then when I say, when I say, here's how I'm going to connect the dots. That's my job. I'm a philosopher. When I start to connect those dots, then that's also not good enough for you. So I guess my confusion.
Well, maybe you should get good at doing what they allegedly are good at.
Neff, I guess my confusion is when they show just the individual dots, that's not proof that the dots are connected. And when I show that it's possible to connect dots, unless I can show the dots, then that doesn't count either in your mind. So I guess my confusion is, do I have to be simultaneously the best philosopher in the world and also the best scientist in the world in order to convince you?
Okay, real quick.
And then I'll give up the mic for the longest time, you guys. Well, the thing is, you need to be able to show the dots can be connected with science. That's all.
Well, but that's what I tried to do.
That's the bottom line. No, not with philosophy, with science. Now, if this scientific evidence exists, if evolution is not just a philosophy but science, you have to move from philosophy to science. Okay, if I'm going to just come right out and say it, if you're not able to do that, if you're not one who, well, I don't know as much about those things as the other guys.
What would be
learn about that and come back and to be able to show that evolution is science and not philosophy.
What would be a strong argument? Would a strong argument be looking at the data and saying, here's a bunch of data, or would a strong argument be looking at how can we connect data?
Well, here's the thing. I want to make a point. Are you familiar, Alien, with the HapMap project?
No, go for it.
Okay, so it's a really, really important project that was done and intended to compile a significant fraction of human genetic diversity, okay? Because there's two competing models here. We got your model that says, all life on Earth, banana plants, dogs, humans, and apes are all related, a universal common ancestry. We look to the biblical-based model, right? Limited ancestry, for example. So if we want to connect the dots, if we want to look at the data, for example, well, in this project, what they did is they examined millions of variants in thousands of people from around the world, and they made this data easily available. So, we can send it to you after, of course. And just a few things that we learned, okay, and we learned this in the present, of course, and this is how we can connect the dots. Also, this is through genetics, okay? So what's inherited sperm and egg, genes, traits, and genetics. That's how we can determine directly the answer and question to ancestry versus like going to a rock or going to a bone found in the dirt as someone like Jackson Wheat would do. Those are not inherited sperm and egg. Genetics are. So this is what we've learned in genetics, that the human genome is young because it shows that shared blocks of our DNA are large and there has not been enough time to scramble them to randomness. Okay, so if we look to genetic processes like recombination and gene conversion, if deep time evolution was true, then those processes should have scrambled these linkage blocks to randomness, but we don't see that. We also see that the human population came from a single source because most of these large blocks are shared among world populations. We can also look at the mitochondrial DNA and the Y chromosome, and based on the empirical method, because we're looking at the data and connecting the dots, that takes us right back to two ancestors, Adam and Eve, mitochondrial Eve, Y chromosome, Adam. Another thing that they discovered in this project as well is that the human genome is falling apart. This is what we see in the present. It tells us that deletions, okay, these types of mutations, they tend to not be shared among populations, but are actually unique to subpopulation. And that's actually further evidence for the youth of the genome that we came, as I said, from a single source population in the recent past. Also, mutations, which you're saying are the designer, are clearly not the designer, they're the destroyer, because the many lines of evidence that we can point to and have pointed to support the fact that human genetic degeneration is real. We are accumulating these mutations. So in the present, if that's what we see is genetic degeneration, if you want to go to the fossil record or something like that and connect the dots, those dots are not going to connect. So if all this evidence and data suggests that our model is demonstrable and what the evidence points to, then why are you still hanging on? Because if all you can give is philosophy and you want to connect the dots, we just connected the dots and we see where the dots lead.
Okay, so you're suggesting that the dots lead to the individual Adam and the individual Eve. That might very well be possible, actually, with respect to humans specifically, because we're talking like there's actually a lot of, again, I'm not Jackson Wheat, so he'd be able to say this in more detail. But there is some degree of evidence, I think, that there's a couple of specific animals in the past that all human evolution has sprung from, right? Which is a very interesting point that I had not expected until I had learned about it in I think it was National Geographic, but that was a while ago. And again, I'm not an expert. The question though is when we're talking, this is the point about the dyslexia point, this is the point about the hair point, like we have to be able to realize that there are some things that are both positive and negative. And so it makes a lot of sense that it all started from one place, but that's a different point than that it has all been backtrack from there, right? Like even in the last 200 years or so, there's a lot of evidence to suggest that people were literally shorter 200 years ago than they are today. There's a lot of evidence to suggest that people were literally not living as long, not as healthy. And so, part of that is what we're eating, but another part of it is just that we're, the people who are able to reproduce are the ones who are healthier. The people who are able to reproduce are the ones who are, able to survive for longer. That's true. And there's evidence for it, even in just human society. This is not something that's just true, in a hypothetical sense. There's a lot of evidence for it.
Alien,
to the point.
Let me make a quick interjection here on the height.
Wait, I'm sorry. Who is this that's saying this?
It's logical.
Oh, okay.
Dude, a couple things. Number one, you seriously need to go study some biology and some genetics, because the plethora of your supposed arguments in the last 15 to 20 years have been completely shown to be the result of epigenetic variables and not the traditional evolutionary concept. And there are papers out the yin yang on the fact that, number one, the slow mutation model is a complete and utter failure. There's one of the papers I read recently is we do not need another synthesis. So if you don't know what that is, modern synthesis is the current, there's extended synthesis for different variables of neo-Darwinism. But literally, over the last three or 4 years, there has become a dramatic push to say that everything that you're arguing for tonight does not remotely explain the modifications and the existence of life from a evolutionary perspective. That is a fact. And the Jackson Wheats of the world, who crack me up, to be honest, but they continue to cling.
I think he's a really smart guy. I've talked to him. He's a really smart guy. But sorry,
I know who he is. I'm not questioning. He may be smart, but the fact that he is still clinging to things that have been utterly discounted in the current research, they have been dropped 20 years ago, and he still argues about them in his videos and in his debates. And he still argues about things that are not even accepted now. They weren't accepted 20 years ago. They sure as hell aren't accepted now. And to continue these arguments when the evidence is growing by the day that the slow mutations over time resulting in new types of organisms being a false assertion. I mean, if you want to go down that rabbit hole, you are trapped in a purely philosophical argument, not a remotely scientific one. And the reverse engineering that you're talking about of, as an example, if let's say I came across a car, I don't know what the hell a car is. I've never seen one before. And I see it and I start trying to figure out how it works. I'm taking off the wheels and the axles and the brakes and the brake. So look at the brake pads and the combustion engine and the exhaust. And I'm figuring out, like, holy crap, here's how that works. Oh, wow. It exerts heat and pushes this. And then the exhaust goes through this pipe. That's really cool. Just because I now know how something works has literally nothing to do with whether or not it could come into existence by chance. And the entire point, we made this point in our discussion the other night, that the human cell, or not just human cell, any cell, is exponentially more complicated from a technology perspective than a vehicle. The code and the logic rules and the programming that is required for all of these different functions that we're talking about, whether or not it's hair to grow longer if you live in a colder environment, or not to grow as long if you live in a warmer environment, that requires the source code function to already be in place. You have to have the source code, which is why earlier I made it. I asked you the direct hand.
I just don't want to forget everything. So can I talk to those 2 points before we move on?
Sure.
Okay, so the first point there was about scientists currently. There are a lot of scientists who believe a lot of different things, right? Of course, there's millions of people who are in the field. There are tens of thousands who are equally expert as Jackson Wheat himself or as Steve McRae. None of us are either of them. And there are people, admittedly, who are creationists and who are experts. That's true in every single field. There are people who disagree with the consensus in every single field. And I don't mean to discount the credibility of people who disagree and are creationist in the field. However, when we're trying to,
I'm not talking about creation. Hang on, dude. You're going down the wrong rabbit hole. The people I'm referring to who are discounting this are not creationists. We're talking about staunch atheists who have been very adamant.
An atheist and a creationist, but yeah.
No, I'm saying they're evolutionists who are staunch atheists. They are not creationists, nor are they theists.
Okay.
And they are very aggressively being like, guys, on a pub. Dude, there's conferences about this whole deal from some of the most prolific and elite academic institutions on this planet that are in agreement that neo-Darwinism and modern synthesis
but
do not even remotely account for all the things they are discovering, and that the entire concept needs to be discarded because it does not. And they're literally writing papers about how this kind of discussions that we're having right now are stupid.
If we're saying that there's difficulty,
there's no point in even having this debate in the first place, because the evidence says it is not even viable or logical.
If we're concerned about some degree of confusion and grappling with issues in the scientific community, I think it's completely legitimate, and we should absolutely look to them, and we should continue to read up on them, and we should continue to be interested in what they're doing, and we should listen to people like Jackson Wheat. We should listen to people like Steve McRae. However, the larger issue is that, we have to look at the aggregate. when the aggregate of the scientific community is saying that the evolution is real, then I think that it makes a lot of sense to say, oh, if the aggregate of the scientific community thinks it's real, they're probably right. Right. I don't think they're stupid. I don't think they're like paid off or something.
They're
right?
often wrong about things,
So yes, so Neff, I agree. But there's a question of Neff. Wait. I agree that scientists are potentially wrong. There are about, let's say, 3-4% of people who are experts in the field might be creationists, something very small, right? So let's say it's possible that 3 or 4% are wrong, or it's possible that 96 or 97% of people who are experts in the field are wrong. I think it's more likely that 3 or 4% are wrong than that 96 or 97% are wrong, right? Now to the second point about the source code point, I 100% agree with you, but that's the reason that I'm saying the source code is that everything in the world is interested in at a genetic level the ability for those alleles, those specific forms of genes, to survive into the future. And then, Dawkins suggests, and this is a little bit more controversial, but I agree with him, that it's also possible once you get sufficiently complicated as an organism for there to be cultural evolution. Now, unfortunately, it's almost 1 a.m, and I have to leave because I have a video come out in the morning on with the libertarian candidate Dan Berman. Taxation is theft. Dan Berman. Yeah.
Do us a favor.
I have some closing arguments before I leave.
Next time.
Okay, man.
Right.
So you are your entire argument completely avoids and doesn't even address any of the points that have been made that completely eviscerate every single one of your positions.
Yeah, obviously, I don't think that's fair.
You said I can make a.
Sure. I'm sorry.
You just did a little promo for your candidate that you're working for, and
I interviewed him.
Just like you did last night. So, thank you. Yeah, I know you're trying to get traffic for your channel, so shut up and listen. To talk about the source code, it has purpose to evolve and advance and all that kind of stuff. You, again, as I talked about earlier, and I don't think you have ever written a line of code in your life, if you actually are going to ignore that the source code, you keep just, the source code just exists, and then it modifies and improves and changes into these different things and has purpose for survival. How do you account for logic rules, syntax, semantics, and pragmatics that are required for source code? If it is source code that is required for any organism to exist, which is a accepted premise in the genetic code, it is a requirement. And new functions and new body plans require new code and new variable functions to exist in a structured format using a universal code base. In this context, the genetic code of DNA. You are completely avoiding the premise, and I'll ask you a direct question. Just because WordPress exists, and PHP, HTML, and CSS, and JavaScript are used to make it execute, could any WordPress website turn into a different one over time by accident without a designer being in place, an intelligent agent, to modify the content, the CSS hex codes, and everything else to create the new website? Yes or no?
Sorry, can you repeat the question one more time?
Two questions. One, have you ever built a website or done any kind of actual coding in your entire life?
No. Am I aware still of how coding works? Yes.
Okay. Number one, does any website that has ever existed, has it required an intelligent agent to write the original source code? Yes or no?
Yes. However, the underlying way that a computer works is still the same way that a computer works. All computers are still based on
I'm talking about the source code.
Similarly, I understand.
You're talking about the compilation and the execution.
The point is that source code is
the source code. The source code get written on a paper.
But source code isn't the component that I'm concerned about, right?
This is why I'm telling you that you are completely avoiding the obvious.
All right, I appreciate it. I'm happy to come on later, but it's almost 1, so I got to leave.
Yeah, this is your last time. This is your last time.
It's my last time.
Basic logic. Yep.
Very well. I appreciate it. Bye-bye.